Hey, it's Dr. J. I'm back with part 2 of section 5.3, decimals and fractions. We just have a few things to deal with today. The first thing we're going to talk about is inequalities between decimals and fractions. So insert an inequality. Either less than or less than or greater than. We're not going to use the closed inequalities, the or equal to or anything like that. So we're going to assume that one of them is strictly greater or less than the other to make a true statement. I'll kind of give you I'll spoil it right now. If I write down a fraction, and then I want you to insert either a less than or a greater than, and then I'll compare it with a decimal. Now, of course, on the homework or on the lab, you can just try one way, and if it's incorrect, it's obviously going to be the other way. So if all you're trying to do is just get through the assignment, you may have already done that at this point. I would warn you or caution you against that in general, because you know that that's not going to be true on a test where you're only going to get one attempt. So if you should probably know. So what I'm going to do is assume that we don't know, which one is greater, which one's less, and then we'll go through the process of how to do it. Now, since this section is primarily about decimals, the whole chapter is about decimals, we are introducing the fractions and using the fractions to emphasize the quantity that is represented by a decimal. I'm going to write everything in terms of decimals, just to make things nice for these types of problems. So what we're going to do is convert 3/8 into a decimal. You can do that with a calculator. 3 divided by 8, and you get 0.375. Okay, so this is 375 thousandths, and this is 38 hundredths. Well, 38 hundredths is the same as 380 thousandths. Yeah, there's an invisible zero here. So if you ever want to turn a hundredth into a thousandth, you just add the invisible zero, and now it becomes a thousandth. And so if you think of these out of 1,000, this represents 380 out of 1,000, and this represents 375 out of 1,000. And so the proper inequality is that 380 thousandths is greater than 375 thousandths. So that would be the proper inequality. I'm going to probably use the calculator quite a bit in this lecture because I think I've already demonstrated all the techniques by hand. If there happens to be one that shows up here where I want to emphasize the hand method, the paper pencil method, then I will do so. I'm also going to double dip on this and just call this example 2 now. So how about this one? So we have 6/7. So 6 divided by 7. I wrote this down incorrectly. Let me correct that. So 6/7 compared to 0.87. So 6/7 on the calculator is 0.857142. 857142. It's just going to repeat forever and ever. This is what we call a repeating block. This is what we call a repeating block. And so when you have a repeating block, you can put a line over it like this. And that indicates, this line indicates that that block repeats itself over and over again. And then we no longer have to write that. That represents an infinite repeating block of decimals, 857142, over and over and over again. Okay. And then over here, it's 0.87. This is what we call a terminating decimal. We're just simply terminating. It means that there are no repeating decimals. There are no repeating blocks. There's no repeating digits, unless you consider 0 as an infinite repeating decimal. Typically, we don't. When you get all zeros, we call that terminating. It's like when you do the long division process and you get a remainder of 0. So 857142, repeating, 0.87, we compare them, 85, 87, we get that the 0.87 is larger. Let's try it out. Normally I do these like part A, part B, part C, but for today I'm just kind of reusing the whole thing here. How about something like this? 2/3 and 0.6. So we got 2/3, 2 divided by 3. When you do that on the calculator, you get 666666666. So this is what we call a repeating digit. It's not a repeating block, but it's a repeating digit. And so we normally put a line above the digit that's being repeated as soon as it repeats. So the very first digit repeats, and then we delete the rest of these. And so this represents the repeating digit 0.6666666, which is 2/3. And then this is non-repeating. This is terminating. And so a repeating 66666 is now greater than a terminating 0.6, which does not have a repeating digit. Let's do one more, maybe some negatives. Haven't dealt with any negatives in a while, so let's do some negatives. Negative 9/8 and negative 1.2. Okay, so 9/8, 9 divided by 8. That's 1.125 compared to 1.2. Now, these are both terminating decimals. Neither one of them repeat. So one thing that's sometimes useful is to put some additional zeros here so that you can compare the size of the decimal part. So this is -1 and, remember we read the decimals and, 125 thousandths. And then this is -1 and 200 thousandths. So which one of these is closer to 0? That would be -1 and 125 thousandths. So intuitively it's as if you're kind of picking the smaller one, but when you're comparing negative numbers, the value that's closest to 0, which intuitively you would think of that as being small because it's closer to 0, because it's a negative number, the number that is closer to 0 is the larger number, and so the inequality would face to the left, or we call that opening to the left. I'm not really going to talk too much more about this. I've already gone on, 10 minutes on this topic. This is really just to have a conceptual understanding of the location on the number line. I'm not drawing the number line, but I'm calculating it using decimals so that you have some sort of intuitive idea of what's going on. I don't want to overemphasize this topic, but I really just use this as an opener to get into what the main topic today is going to be, and that's that we're going to be talking more about these terminating and repeating decimals. So decimals fall into 3 categories. So something like, I don't know, let's do an easy one, 1/4. Yeah. So 1/4 is 0.25, also known as a quarter. This is called a terminating decimal. Or simply terminating. So that's the first category. I should be careful here. I don't mean one. One is just category number 1. Category number 1. Category number 2. Something like 1/6. 1 divided by 6. I already knew that one. It's 0.1666666666666. Now notice the 1 is not repeating. Yeah, it's only the 6 that's repeating. So we rewrite this as 0.16, and then we put the bar above the digit that's repeating. And this is category 2. This is called a repeating digit. And we're going to get more into this. The terminating decimals are nice ones that you probably learned in the previous section, like 1/2, 1/4, 1/5, 3/4, things like that. There's several other ones. 1/8, 1/16. They all terminate, and we'll get more into figuring out which ones terminate and which ones don't as we go through. The repeating digits are very common when you have multiples of 3. So 1/3, 1/6, 1/9. Whenever the divisor is a multiple of 3, you typically get a repeating digit. So 1/3, 1/6, 1/9, things like that. 2/3 also does the same thing. The third category is a strange category. It happens with denominators like 7, or 11, or 13. I'm going to use 7 as an example. When you divide by 7, you get 0.142857, 0.142857, and then it repeats again, 142857. This is what we call a repeating block. So the entire block, 142857, is repeating. So those are the 3 basic categories. Now, this is one example from each category. But in general, if you just want something to memorize, if the denominator is 2, 4, 5, 8, 10, you might as well just stop there. Those are the ones that are going to terminate. If the denominator is 3, 6, or 9, you're going to have a repeating digit. And then if the denominator is 7, 11, or 13, you're going to have a repeating block. Now, of course, there are millions and millions and millions of possibilities. In fact, there's infinitely many possibilities. So I just kind of gave you what I call a handful, right? The ones that you can kind of just work with on a daily basis. And then if there's one that's sort of strange or falls outside of that handful, then we can take care of that as we get to it. So in the next few examples, I'm going to be asking you, does the decimal terminate? Does it have a repeating digit? Or does it have a repeating block? So given 5/3, let's do 4/3 actually. I changed my mind. I want it to be slightly different than what we've already done. Convert it to a decimal. Okay, so let's just do that first. You might memorize this. 4/3 is 1.33333. You could do that with mental math or use your calculator. 4 divided by 3 is 1.3333333. I'm not sure if you could see that. There it is, 1.3333333. So that is 1.3 with a bar above it. Some people, this is really a stylistic notion. They like to show, I'm kind of one of those people, they like to show a couple of the repetitions before putting the bar. But that's not the way our book does it. That's not the way the homework does it. So I'm sticking with the traditional, put the bar as soon as you notice it repeats. You don't have to wait a couple repetitions before you see the repetitions. Okay. This is a repeating digit. What digit repeats? All right. What digit actually repeats? Well, it's not the 1. The 1 doesn't repeat. It's the 3 that repeats. So we have a repeating digit. The digit that repeats is 3. Okay. And then if you want to enter the decimal by placing as many of the digits as can fit in the blank. Now, if I was collecting paper homework, I would just have you do this if this was on paper. I used to give this assignment on paper, and I would just have people write 1.3 with a bar on top of it. But on the computer, I've really tried to make a system that allows you to put that bar above the number, and I can't figure out, or it's just not an option that we have. You can see the little drop-down menu that gives you all the different options for formatting. That's not one of the options, and despite all my efforts to try to make that become an option, it's just not optional. So I want you to enter the entire decimal, not just the repeating thing, but the entire decimal by putting as many of the digits as you can fit in the box until you run out of space. And that will tell my answer key that you understand that it's got a bar above it. So in other words, this is our adaptation to the bar symbol because we don't have a bar symbol to use. Okay. Again, I'm going to reuse a lot of this, so let me just go ahead and change this to number 6. Let's give you a different fraction. All right, how about 16/9? It's almost the same question. 16/9 is 1.77777777. This is again, repeating digit. What digit repeats? 7 repeats. And then enter the decimal by placing as many digits as you can fit. 777777777. Okay. I kind of wish that would have been example 7. So here's example 7. Five 13ths. So I already did 5 13ths for you. It's 5 divided by 13, 0, 3, 8, 4, 6, 1, 5, 3, 8, 4, 6, 1, 5. So you'd say 3, 8, 4, 6, 1, 5 with a bar over it. This is a repeating block. What block repeats? So in the block, just type the digits that repeat. 3, 8, 4, 6, 1, 5. 3, 8, 4, 6, 1, 5. 3, 8, 4, 6, 1, 5. 3, 8, 4, 6, 1, 5. And then on the computer, enter the whole decimal, as many as you can fit. 3, 8, 4, 6, 1, 5. 3, 8, 4, 6, 1, 5. And if you don't get, just when you run out of space, stop. Don't worry about how many digits actually fit. Okay. How about example 8? 5/8. So 5/8. 5 divided by 8. 0.625. Yeah, no repetition. So this is a terminating decimal. What digit or block repeats? No digit or block repeats. So just put 0, meaning none. There is no repetition, so just put 0. Yeah. There's actually a reason why we put 0. Technically, over here, there's an infinite number of zeros that repeat. But you won't see that on the calculator. See, the calculator just terminates 0.625. all decimals have this repeating block of, all terminating decimals have this repeating block of zeros, or repeating digit of 0 that goes on forever and ever. So that's why we accept 0 there. All right. And then for the last part, because it terminates, don't do any repetitions. Just type 0.625, 0.625. That's it. So you'll have lots of extra space on that one because there's no terminating. If you really want to get fancy, you can fit as many zeros as you possibly can in there. It'll still mark it right. I know these aren't the most exciting problems, but if you've never seen this before, it can be, if you open up the assignment, you're like, how the heck am I supposed to do that? So this is mostly a walkthrough on how to enter these answers here. The next, I'm going to go through a few that are very common, that occur all the time, not just in this course, but in several of our courses. One of them is 1/6. I already mentioned 1/6. That is 0.166666666. So you put the bar above the 6. And this is a repeating decimal, or sorry, repeating digit. I want to be very clear. It's a repeating digit. Sometimes we call it a repeating decimal. I know what you mean when you say that, but technically it's a digit. What digit repeats? Well, the 6 repeats. The 1 does not repeat. And then fit as many of them in the screen as you possibly can. I think we did this a few minutes ago. I didn't present it in this form. Another one that's interesting and very common is 1/9. So example 10, 1/9. One-ninth is 1 divided by 9, which is 0.11111111, or 0.1 with a bar. This is again a repeating digit. What digit repeats? 1 repeats over and over and over again. And so just fit as many repeating 1s as you can in the box until you run out of space. All right, those are all the introductory examples. I gave you 10 introductory examples of decimals, and in particular repeating decimals and repeating blocks. 9 is an interesting character, yeah, because it's 0.11111111. So we're going to sort of store that away in our mind. We'll come back to that later. And then I'm going to do multiples of 9, like 99 and 999, so we can see that this behavior is indicative of numbers involving 9s. So let's do 1/99th, 1 over 99. 1 divided by 99. 0.01010101, etc., etc. So this is a repeating block. So the block that repeats is just 0, 1. You don't need to put the decimals in this answer. I just want to know what is the block that actually repeats. Down here, you should put the actual decimal like you did way up here at the top. You're basically just taking this from the beginning and bringing it down here. 0.0101010101, and when you run out of space, that's fine. I don't know. It's really hard to make a lot of variety with this, but let's do one that's not so simple as just 0 ones, but we should probably store that in our mind and come back to it later. How about 128/99ths? That's 1.292929292929. So that's 1.29 with a bar over it. Again, this is a repeating block, and the block that repeats is 29. And then down here, 1.2929292929, etc., etc. You might start to notice something. Yeah. With a 9, dividing by 9, you get one repeating digit. When you divide by 99, you get a repeating block of 2 digits. So that tells us, or that at least alludes to the fact that if you had 586 999ths, notice what happens. 586, 586, 586. Ah, I think we're on to something. Look, 586 999ths. That's just a repeating 586, 586, 586, 586. So what block repeats? 586. And so on your computer, you would just take this answer up here, 586, 586, 586, 58. Don't worry if you run out of room. Just fit as many as them as you possibly can in the box. Did we already do a 7 or a 13 or an 11? We'll come back and do more of those in a minute. Okay. So why did I bother going through all of that other than I want you to be able to get the right answer? And yes, I want you to be able to get the right answer, but I also want you to... Too many examples here. I want you to be able to go the other way. And that's really kind of what I've been leading towards in this presentation. What I'd like us to be able to do is to start with one of these repeating digits, or maybe something like this, so it's written out in that form. Because it turns out I can give you a question that has the bar above it. I can do that. It allows me to put the bar. It just doesn't allow you to put the bar. So in the next few examples, I want to go the other way. I want you to take a repeating decimal, something like that. So there's your repeating decimal, 3.0166666666. Write it as a fraction. And I think the term I use is a simplified fraction. So I don't want any mixed numbers. I want a simplified fraction, also known as reduced. Or reduced to lowest terms or something like that. Now there's several different ways to think about this. One way is that you've played around with your calculator enough and you sat here and played around with it until you got that to happen, right? I mean, that is a possibility. You go, okay, 1/6, right? Remember, 1/6 So you can kind of play around with it a little bit. So you have to have something to kind of build on top of. So look for a pattern that you recognized before. So we know that 1/6 was 0.1666666. Okay, so we sort of have a match here, right? But now we want to move the decimal over to the left one place. So if we divide it by 10, we get 0.16 divided by 10. So now take your calculator and divide it by 10, and look what happens. You get this. So you're sort of constructing the answer piece by piece. Yeah. By the way, 1/6 divided by 10 is the same as 1/60th. Yeah, 1/6 divided by 10, you flip the 10, make it 1/10, change the division into multiplication, and now it's 1/60th. Now look how close you are to this. Yeah, you've almost got the answer. All you're needing is the 3. Just remember that the decimal point is and means plus. So 3 and, or 3 plus 1/60th. And so the answer is 3 and 1/60th. And I don't want any mixed numbers. So we're going to do the trick where you multiply and add. That's 181/60ths. And that's your answer. I realize that this process is not a recipe problem. I cannot just give you first do this, then do this, then do this. It's really a constructive process where you have to first look for something that looks familiar, lay down a fraction that you know is going to sort of match what you're looking for, and then build on top of that. Let's try another one. Same question. So given 7.444444444444 forever and ever. Write this as a fraction. And then, of course, it has to be reduced or simplified. All of these techniques that I'm teaching you, ignore the whole part until the very end. So you kind of know, okay, first I have to worry about the repeating part. So you got to start with a recollection. You have to remember something. And so one of the things to remember is that 1/9 is 0.111111111. That's a repeating 1. All right, if you don't have that recollection to build on, it's almost impossible to get these. It's not impossible. You could, play with your calculator long enough and eventually get a repetition of 4s, but you really want to build on something. All right. So 4 times 1/9 is equal to 4 times 0.11111. Remember, 4 times 1/9 is the same as 4/9. You just multiply 4 times 1 and 4 times 1, and then 1 times 9. And then you multiply 4 times 0 is 0, and 4 times 1 is 4. So instead of having a repeating 1s, you now have a bunch of repeating 4s. And you might just memorize, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, that's 1/9. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, that's 2/9. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, that's 3/9. Yeah, but 3/9 is the same as 1/3. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, that's 4/9. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, that's 5/9. So you might as well just memorize that. 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, that's 6/9. So that's a quick way of building your repeating digits using a denominator of 9. And then finally, the last thing you want to do is add the 7th. The 7 and 4/9 is 7 plus 0.4. You're adding 7 to 0.4, so that's going to become 7 and 4/9 is equal to 7.44444. So this is 7 and 4/9. Just in case you can't see that, I wrote it up here. 7 4/9. Now I do say reduced fraction. This is not a reduced fraction. You got to rewrite it. 7 times 9 is 63. 63 plus 4 is 67/9. And so that's the answer. Not sure if we need the calculator anymore. Let's put that away. All right, so that's the concept of doing it with digits. Maybe I'll do one more, because I'm about to move on to the blocks. So example 16. Given 1.033333333333, right, as a fraction. And again, simplified or reduced. I shouldn't really have to say that, but I'm saying it anyway, just to be safe. All right. Now, I got to be careful. The 0 is not repeating. Just the 3 is repeating. I'll do one in a minute where the 0 is also repeating, and that's a little bit different. But this is just the 3. So first, let's do a recollection. 1/9, that's what you want to build your repeating digits on. That's 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So 3/9 is 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Yeah. Which is the same as 1/3. Okay. But we want to put a 0 here, which means we want to move the decimal one place. So we're going to divide this by 10. And then remember, to divide by 10 is the same as to multiply by 1/10. So that's going to be 1 over 30. And then when you divide a decimal by 10, you're going to move the decimal one place to the left. So the decimal moves one place to the left because you're dividing it by 10. And so there you go. You got your repeating 0.03333333333. And then finally, you just need to add 1 to both sides. So just adding 1 to both sides. So that's 1 and 1/30 is 1.03. And then you want to write this as a simplified fraction. So that would be 31/30. There's your answer. I guess I said I was going to put away the calculator, but you can actually keep it out for checking. 31 divided by 30, and there it is, 1.0333333333333. All right. I don't know what else to say. I wish I could say, step 1, step 2, step 3, but it's really not like that. It's start with something. I guess that is step 1, but it's a constant, back and forth. It's a little bit of a crafting process as opposed to, so you're constructing this as opposed to solving for something. Now, solving is very mechanical. Constructing is a little bit more artistic. You got to kind of play around with it a little bit, and you might not get it right away. Let's try one where the digit actually repeats, something like that. 2.05050505050505 forever and ever and ever. All right. Again, you need to have a recollection, right? 1/99th is 0.1010101. Or 0.1 with a bar. All right, so this is probably the most important step. Yeah, this is the key step. If you don't make some sort of recollection, now by the way, all of these recollections are in the homework, so you can just kind of flip back and find a decimal that you've already done previously in the homework and use that as your building block. All right. Always do the whole part last, if there is a whole part. Next thing we want to do is make it a repeating 5. So we're going to multiply both sides by 5. It gives us 5/99ths is 0.5050505. And then you can kind of test it as you go along. 5 divided by 99 and make sure that you're right at 0.5050505. I don't know if you can see that. There we go. That's a good one. 0.50505. So that's where we are now. And then finally, add the 2. And that'll be rewritten as 2 and 5/99ths. So that will be what? 2 times 99 plus 5. That's 203/99. And that's your answer. $203.99. Just a couple more to go. Example 18. Zero point one 0.1027, and the 0, the 2, and the 7 are repeating. I'm getting a little lazy with the instructions, but I'm going to need a lot of space for this one. So it's the same problem. So I'm taking this, I want to write it as a fraction. Okay. There is no whole part. There is a tenths place, but it's not repeating. And then we have 3 repeats. 027, 027. So remember, from earlier, 1 over 999 is 001 repeating. And if you don't believe me, do it. 001, 001, 001, 001. Okay, that's 1 over 99. Now I'm ignoring this for now. I'm just looking at this repeater. That's what I'm trying to figure out. So if I multiply it by 27, you're going to get 999. Be careful that you don't multiply the 27 times the 999. The 27 gets multiplied by the 1. Yeah, and then the denominator, there's an invisible 1 times 999. And that should be 0.027 with the whole 027 repeating. And I would check as you go along. 27 divided by 999, and there you go. 027, 027, 027, 027. Make sure that the 0 is actually part of the repeater. I've screwed this up myself where I get the first 0 is right, but then after that it just goes 27, 27, 27, 27, 27. So you got to make sure that the 0 is also repeating. See how the 0 shows up in each spot? Okay. All right, now we got one more problem. We got one more problem, and that is the decimal point is in the wrong place. The decimal point's in the wrong place. Look where the decimal is, and look where it is up here. So we need to move the decimal over one place. So it's dividing by 10 again. So that'll make 27 over 9990, 9,990. Again, I'm skipping that step. I hope you've caught on to that by now. You're just multiplying the denominator by 10. Okay. And then on the right side, you're going to move the decimal place one place over. So when you divide a decimal by 10, you move the decimal one place to the left, and then add a 0 here. Right. Now, in all of my previous examples, I was adding in the whole part. Now I need to add in 1/10. Yeah. If that was a 2, then you would add 2/10. If that was a 3, you would add 3/10, and so on and so forth. That's just a 1, so I'm going to add 1/10. So I'm going to go down here and go 1/10 plus. Yeah, and then I'm going to go over here plus 1/10. And I am totally running out of space here, so I'm going to have to come up here and keep working. So now I have 1/10 plus 279990 equals 0.0027 repeating plus 0.1. I just copied it down here. So now the right-hand side is 0. I'm lining up the decimals. That'll be 1027. So we got it. See? These match. And now I just have to simplify this. 1/10 plus 27,990. 9,990ths. Oh, we need an LCD. It's just going to be 9,990. So we're going to multiply this one by 999 and this one by 999, 999. So now we have 999 over 9,990 plus 27 over 9,990, which equals 999 plus 27. I could have done that in my head. 1,026 divided by 9990. And there's your answer. And you want to check it? Just use your calculator to make sure you get this. Let's see. 1,026 divided by 9,990. And exactly what we thought we would get. 0.1. And notice the 1 never repeats. And then the only repeating is 027, 027, 027 forever and ever and ever. I want to just, before I do the last two examples, tell you that this lesson is important for two reasons. One, I want you to get the right answer on the assignment. But that's actually not the most important reason. The most important reason is not just getting the right answer on the assignment, but it's the conceptual understanding of how repeating decimals behave. If I can impart to you that, even through trial and error, through a little bit of frustration, through maybe some guessing, you will develop the ability to tackle more complicated questions in a much more efficient way. In other words, it alleviates future suffering. This is the medicine for a disease that you don't have yet. It's coming down the road. You know, we're going to get into algebra. We're going to get into advanced algebra and word problems and some, application problems involving decimals, in which having a good, well-rounded understanding of these decimals becomes important. Yeah, I mean, I want you to get the right answer. Yeah, and I want you to pass the class. Sure, yeah. But I know that I'll see you on the other side, and when we get there, this is something that's going to become very important, all right? At least the strategy that we're using. I'm not saying that you might never see these problems ever again in your life, but I've planted that knowledge, and so that's really what I'm going for, okay? So keep that in mind. This is a philosophy. Okay, let's see, 5.0066, and this time everything is repeating. Well, everything except the 5. Again, it starts with a recollection. You got to remember something. You got 4 repeaters, a repeating block of 4. So that's 9999. Yeah, let's double check that. 9999, 1 divided by 99999, you get 0.0001, 0001. That's a block of 4. All right, this is what we call a seed. Yeah, that's what you're going to grow everything on top of, or it's a structure, it's a framework that we're going to grow this on top of. So now we have to turn it into a 66. So we're going to multiply it by 66. When you multiply a decimal that only has a 1, that's the only non-zero digit, it just replaces these last 2 digits with that decimal there, or with that digit 66. On this side, you're going to get 9,999. I don't think I tried to reduce the last answer. I should really be trying to reduce this. This is divisible by 3. 66 is 22 times 3. And 9,999 is 3,333 times 3. Yeah, let's double check that. 3,333 times 3. Exactly what I just said, 9,999. So we can cancel that out, and we're going to get 22 over 3,333. I don't think that those are both divisible by 11. You could try 3,333 divided by 11. Oh, it is. Yep. So that's 11 times 2 and 11 times 303. That's neat. I wasn't expecting that. Yeah, I guess that makes sense. 303 times plus 3. You ever know the 11 trick? That's the 11 trick. When you multiply something by 11, you just stagger it. 303 and then 303 staggered, off by 1, and then add them up, and then you get 3,333. I just wanted to do a conceptual check to make sure. So this fraction represents only the decimal portion. So now we're just going to add 5. And so we have 5 plus 2 over 303 equals 5 plus 0.0066. So that'll be 5.0066 repeating. And then over here, 303 times 5 plus 2 is 1,517 over 303. And that's your answer. This is just to check that I've done it correctly. Don't enter this as the answer because that's just the question that I gave you. But I'm going to use it to check. If I take 1,517 and I divide it by 303, I should get 50066, 0066, 0066. It's going to go on forever and ever. Okay, I think that'll about do it. The only thing I want to mention before I do it, I guess I could just call this the last example. And this last example, I'm really just going to give you it because these are strange denominators that I mentioned earlier. If you have a denominator of if you have a denominator of 11, 7, 11, or 13, you get these repeating blocks. And I just want you to have them all in one list. So I'm calling this example 20 just really as a goodbye note here. Rewrite each fraction as a decimal. Actually, let me say it the other way around. Rewrite each repeating decimal as a fraction. I wish I could tell you that this one had some sort of magic to it, but it really doesn't. It's just you have to know it. So 1, 4, 2, 8, 5, 7. I'll just write them all down and then we'll figure them out together. You could learn these just by playing with your calculator. Six, 9, 2, 3. There we go. There are more. I just want to show you these three. The A and the C are probably the most important ones. A is 1/7. Yeah. And there is no magical technique for doing this. There's not. I can't show you a step-by-step procedure for doing this. This is just a fun fact. 1 divided by 7 is 0.142857, 1428571, and just repeats over and over again. This one, there is actually a step-by-step method. You could use the 99 trick. Yeah. So this would be what? 9 over 99, right? We just did that a minute ago, right? Because if it's 0.10101010101, that's 99. That's 1/99th. So just multiply that by 9, and so that one is 1 over 11th. 1/11th. 1 over 11. Okay. And then here, this last one, you just have to know it. It's a fun fact. It's 1 divided by 13. So out of all three of these, the only one that you could actually do using the steps that I showed you is part B. Yeah. So this is similar to example, I don't know, 18 or something like that. I'm not sure exactly what number it was, but one of the ones we just did a minute ago with the 99 in the bottom. But A and C, you just have to memorize the fun fact. And if it's not fun, at least you have something to look forward to. We'll be wrapping up Chapter 5 relatively soon. I'll be making announcements about which sections we're going to cover before we finish Chapter 5. There might be some wiggle room there, but I'll just wait to report back to you later. But until we meet again, I hope you had a good time. This is Dr. Jordan. I'll see you on the internet.